All right, guys, so now let's look at our ultimate differential equations example, if you will. So part one was just going over the fundamentals of knowing how to do all the steps and whatnot. But this question is more reflective of the level that you're going to be tested somewhat on the AP exam. Okay, so let's go to begin. If you notice, we have a slope field also incorporated with this differential equation. Okay, so the slope field is a representation of this differential equation. And we need to remember that the differential equation is representing the slope, if you will, the derivative. Okay, so let's say that I'm going to look at various values, and I'm saying like 0, 0, 1, 1, or even 3, 0, or 3, 1, and so on and so forth. All these points I'm going to use in this equation to get the slope. Okay, now remember, there are patterns that exist, okay? And if you identify them, it makes graphing this a lot easier. For instance, let's concentrate on y being 0, otherwise our x-axis. So if y is 0, we know the entire numerator is going to be 0 for this differential equation. Okay, so the slope will be 0 over 2 every time that y is 0. So on the x-axis, I'm going to go ahead and put all these mini horizontal tangents that show a slope of 0. Now let's say that y was 1. Okay, if y was 1, then all we're really looking at is what is the x value? And we're going to divide that by 2. So if x was 0, 0 divided by 2 is still 0. 1 divided by 2 is 1/2. If x was 2, then 2 divided by 2 is 1, so that 45-degree angle. And if x was 3, it'd be like 1.5. Okay? Now, if x was negative 1, again, y is 1, so if x was negative 1, it'd be a negative 1/2. Whoops. So not necessarily a 45-degree. And if x was negative 2, it'd be a 45-degree angle right there. So now let's go, what if y was 2? Well, if y was 2, these would cancel to a form of 1. So all I need to do is, when y is 2, is look at the x value. X is 0, x is 1, steeper at 2, steeper at 3. Negative 1, okay, and negative 2, a little bit steeper. Now let's look at what if y was a negative 1. So if y was a negative 1, it's basically going to be the reciprocal of that, or the negative form that is of that. Not the reciprocal, but the negative form. So 0 is still 0. Instead of this being 1/2, it's going to be a negative 1/2. Instead of this being 1, this is going to be a negative 1, and so on and so forth. Negative 1.5, a little bit steeper. We have negative 1/2. Whoops. So where we had a negative 1/2. So again, if y is negative, it's changing all of this. So if this was negative 1/2, it's now going to be a positive 1/2. This was a negative 1, so now it'll be a positive 1. And there is my slope field. Okay, so now let's look at part B. It says, graph or do a sketch, if you will. Actually, it was right here, the sketch, the slope, which we've already done. But it wants us to go through 1, 1. Okay, so write an equation for the tangent line to the curve of f of x through 1, 1. Okay, so if I wanted to look at this, and I'm looking at 1, 1, and looking at the equation of the tangent line of whatever the graph is, like we don't know what f of x is. We know it goes through 1, 1. So if we were to sketch it, we could say it probably goes through here, then goes, probably goes through here, touches there, kind of goes up, and then kind of comes down, and then kind of goes back up. Something like that. It looks like it would fit within the slope field, okay? And the equation that we're looking for is this tangent line. So it says, write the equation for the tangent line that touches at 1, 1. So it's basically saying, write the equation of that line right there, if it was there. Okay, and then we're going to use this equation, whatever it is, to approximate what would 1.2 equal as a y value. So let's go ahead and plug this in. So we have y minus y1 equals m times x minus x1. This is our tangent line equation. We know that our input is 1, so that'll go here. And we know that our output is also 1, that'll go over here. Okay, so now we have to find the slope, okay, which is our m value at this point. So at 1, 1, by plugging it over here, we know that the slope became 1/2. So we're going to put 1/2 for a slope, x minus 1, and then y minus 1. Now, this is the equation that will help us approximate what the y value is, which is right here, at 1.2. We just have to put 1.2 right here in this equation. Okay, so 1.2 minus 1 is 0.2, times 1/2, or otherwise divided by 2, is going to be 0.1. So we have 0.1 on the right side, and we have y minus 1. So we'll have y is equal to 1.1. So write an equation. We've already done that. Use the equation to estimate what f of 1.2 would equal. In this case, it would be equal to 1.1. Okay, so now part C. It says find the particular solution for f of x. Okay, we know that with all the practice that we got in the part 1 video is we're going to do a separation of variables here to find that f of x equation. And we're going to use the initial condition, which is 1, 1, which was given to us as 1, 1 like this. Okay, so this is our x and y value. It was given to us here. It's given to us again here, just in a different form. But we're going to find a particular solution in order to find what it would equal with that equation, with the actual equation of 1.2. Remember, this is an approximation. This equation of a tangent line is an approximation, and when we find the answer to C, that's the exact. That's not an approximation. Okay, so let's go ahead and do this. We have dy over dx is xy over 2. Separation of variables tells us we need to move the dx's to the right and the y's to the left. So I'll keep that 1/2 over here to the right, just like we did on part 1 video. As far as the examples that we did, we kept the constant wherever it was at. And I'm going to constant multiple rule pull that 1/2 out. Now moving the y to the left, I'll have dy over y. Then I'm going to integrate as well. And this is a much easier example to integrate compared to the ones that we did on that part 1 video, okay? So this is a natural log of the absolute value of y. This is x squared over 2, which will multiply with the 1/2 to get x squared over 4. And then we're going to go ahead and put the plus c here. Now, our input was 1 over here. Our input was 1. We're going to plug that here. Our output was 1. We're going to plug it here so that we can find our constant. So we have the natural log of 1, which is just 0. So I'm just going to go ahead and put 0 there. 0 is equal to 1/4 plus c. So c is a negative 1/4. We're going to take this general solution, and we're going to, so this general solution, we're going to take it and make it the particular by using this c value that we just calculated right here. Okay, so let me move this up over here. We have the natural log of the absolute value of y is equal to x squared over 4 minus this 1/4, because we're adding this c value of a negative 1/4. Now we just have to find this as far as getting y by itself. So we're going to apply a base of e to both pieces. Remember that this is my power or my exponent, and this is now my exponent. And rules from Algebra 2, exponential rules, again, we know that x squared times x cubed is adding x2 plus 3. We know that x squared raised to the third power is multiplication to become 6. So up here was x to the 5th. This is x to the 6th. And if we had something like subtraction going on, it's because we would normally have divided. So 2 minus 3 is going to be this x squared divided by x cubed. And that's what's going on here. I wanted just to quickly show you that you have x to the x squared over 4 divided by, sorry, that's e that is, e to the x squared over 4 divided by e to the 1/4. Okay? And then over here, this cancels and you're just left with y. So this is my equation that I now have to apply this plus or minus to. Remember, like we did on the other video, when we ultimately get rid of this, it has to be a positive or a negative version that's there or basically applied to the other side. Well, let's check it. Since we're plugging in our 1 right here as our input for x, we would have e to the 1/4 over e to the 1/4 would equal a positive 1. Well, we need a positive 1 with our initial condition. So we're going to go ahead and make this the positive version when we end up removing these y's. And this would be my equation. This gives us our answer, which you could put it as f of x because they were asking for that. F of x for your particular solution is e to the x squared over 4 over e to the 1/4. And you could do it like that, or if you choose to leave it like this, you could, either way is going to be correct. So let's say we left it like this. Okay. Now, if I wanted to then solve, use your solution to find 1.2, then we would put 1.2 here. So 1.2 squared is going to be 1.44 divided by 4. We're obviously going to need a calculator for this as far as to figure out what exactly that is. Okay, so let's come over here. This was from a previous example. Let me clear storage. And I'm going to go ahead and put this equation in, okay? I'm going to go ahead and store this function as e to the power of, it'll be x squared over 4, and it's going to be over e to the power of 1/4. And I'm going to store this as my solution, my particular solution that I found as f of x. So now if I want to find what is f of 1.2, there it is. Okay, it's 1.116. Now, remember on the AP exam by default, you should do at least 3 decimal places, at least, unless it's otherwise specified. So we're going to say 0.116. So f of 1.2 is approximately, okay, 1.116. Now notice that we got 1.116. We're up here in part B, we got 1.11. Very, very close to this answer that we got here. Now remember, this one right here that I'm doing the arrow right now with is the exact. This one up here with the equation on the tangent line was an approximation, okay? So when it says for part D, compare the estimate of f of 1.2 found in part B with the actual value of 1.2 found in part C, what was your estimate for part B, the underestimate or the overestimate? Okay? And then use your slope field to explain why. So let's think about this. First of all, it's going to be either an underestimate or an overestimate, but it depends on the slope field, okay? So I'm going to go over here where this was all found at 1.2, or sorry, at 0.11. And because I know that the derivative there is positive, okay, so f prime of x is positive, that means f of x is increasing. Which makes sense because f of x, let me go ahead and highlight this, f of x increasing kind of showed at that point it was on a piece that was increasing. Okay, so if it's increasing and my approximate value is asking, was that an underestimate or was that an overestimate? Was part B an overestimate or an underestimate? You're going to compare that 1.1 to this 1.116, okay, which is the same as this. So this one is going to actually be an overestimate because it wasn't necessarily this 1.116 that it had to be. It was an overestimate in the fact of because the f of x was increasing, it was going to be an overestimate. Okay, actually, I don't know why I keep saying an overestimate. It's going to be an underestimate, okay? Because the exact was 1.116, okay? I don't know why I was just saying that, but 1.100 is obviously less than this 1.116. So part B was an underestimate because you're saying like this, then the actual answer that was 1.116. And that's what we have. And the explanation would be simply that this was less than that 1.116.